All right, so again, we are on page 7, and we're going to be talking about parallel and perpendicular lines today. And the first thing we're going to just look at is what makes parallel lines versus perpendicular lines. So first off, take your arms and make parallel lines with them. What do parallel lines look like with your arms? All right, perfect. Two lines that don't intersect. So they could go up or down, they could go diagonal, they could go sideways like an equal sign. But they're just two lines that are never going to touch. So you just draw two parallel lines there. And if you have two lines that are parallel, what do you think is going to have to be true about their slope? They have to be equal or the same. Okay, so parallel lines are always going to have equal slopes. Now perpendicular lines, they intersect, but particularly what specific angle do they intersect at?
They have opposite slopes.
Okay, yep, that's good. That's part of what we're going to be getting to here in a second. But what, like they're going to intersect, but they intersect at what kind of an angle?
90.
A 90-degree angle. So we can draw perpendicular lines here, and they intersect at a right angle. Remember that little box means a 90-degree angle. And so, Evan, like you said, the slopes that they have, there's two things. They have opposites, which means we're going to change signs. And they also have reciprocal, so they're flipped. So for example, if we had 3 halves, positive 3 halves, the opposite reciprocal of that, if this one's positive, you have to change your sign, so it would be negative, and reciprocal means you have to flip it. Okay, so negative 2/3 and 3 halves are opposite reciprocals. What about the other, if I had -2, so the person next to you, what do you think the opposite reciprocal of -2 would be? Think about what number is underneath that 2. All right, so what number is really underneath this 2?
1.
A 1. So when we're talking about the opposite reciprocal, first thing we have to do is change the sign. So the sign would be positive or negative? Positive. And then we have to flip this, so it would be
positive 1 over negative 2, or would it just be positive altogether?
all positive. So we're just thinking of the whole thing. This whole fraction is negative, so the whole fraction for the opposite reciprocal will be positive, and then we just flip it. Okay. All right. So now that we know the types of slopes each one of those have, we're going to just practice. If we can look at two equations, how do we get their slope? So turn to page 13. So we have a list of equations here, okay? And if you want to, it does say like parallel lines, so it says determine whether the given lines are parallel, perpendicular, or neither. Neither just means they're going to be intersecting. But remember, perpendicular means they intersect but at a right angle. If they're not opposite reciprocals, they're not the same. They do intersect, just not at a right angle. So if you want to follow along with the color scheme, there are pencil boxes in the back. You can grab a pencil box and there's some highlighters in there. If you don't really care and you're just going to write parallel, perpendicular, or neither in the box, that's fine also. I don't care. But if you like the color, if you like to see the colors, there's pencil boxes in the back you can check. So if we look at, let's say, this one right here, okay? Again, we're trying to determine parallel, perpendicular, neither. What we just talked about, parallel lines are going to have what kind of slopes? Same or equal. Okay, so you might want to make a note, equal slopes. Or same slopes if you prefer that. The perpendicular lines are going to have that opposite reciprocal slope. So again, change sign. Change your sign. And flip your fraction. And then the neither just means they're going to intersect. Those are going to have just different slopes. So for this top left box, what equation or what kind of equation is it in already? Slope intercept or standard? Are those top left in slope intercept or standard form?
Slope intercept.
Slope intercept, perfect. And when we have slope intercept, it's very easy to find the slope, which is what we're going to need to do here. We need to figure out the slope. So for this first one, our slope is equal to 3 over 1 or 3, yep. For the second one, our slope is also 3 over 1 or 3, right? So what do you notice about those two slopes? They're equal slopes, so what would we know about these two lines? They're parallel, so we would just make a note here, parallel. If you want to grab the highlighters, you take a yellow highlighter and shade that in. If you don't want to do that, that's fine, I don't care. Let's take a look at the one underneath that then. What do you notice about these two equations that are underneath it? They're in what form? Are they in slope intercept like the one above, or are they in standard? They're in standard because they're x and y are on the same side. Can we pull out the slope just by looking at the standard form? Like we were able to here? No, we have to do some work, right? So, you might need some paper. If you need paper, let me know. I can get you some paper. Because you're going to have to do some work. If anyone wants paper, raise your hand. I can give you some. You can squeeze it on somewhere. Then let's find them. Good? Grace, you good? You need paper? You good? Liv, you good?
Yeah.
You need paper? Anyone else? Okay, so we're going to write this first equation here. 2x plus 7y equals 28. Again, we're trying to get into slope intercept form. That was one of the skills that we had on our last quiz. So we're doing PEMDAS backwards. Okay, we're going to undo the addition subtractive. We're trying to get the y by itself. So we're going to move that 2x to the other side. So we're going to subtract 2x. Remember, these are not like terms. So I'd have 7y equals, again, these are not like terms, so I always write the x first, negative 2x plus the 28. And then I would divide everything by 7. So negative 2 over 7, I'm leaving that as a fraction. Negative 2/7, leave it as a fraction. Then we have our x, and 28 divided by 7 is 4. For the bottom one, I'll just do it right underneath it. Again, we're trying to get the y by itself. So I'll subtract 7x. So again, these are not like terms on the right side, so I'd write that as negative 7x plus 4. And then we have to divide everything by -2. So that would give us the equation for this one. Y equals negative divided by negative is positive 7/2. X 4 divided by 2 is 2. So this one has a slope of 7/2. And the top one has a slope of -2/7.
Do you have tissues?
Yep. So if I have a slope of -2/7 and another slope of 7/2, what do we notice about those? Are they parallel, perpendicular, or neither? Parallel. Parallel is when they're equal. Remember, one of them is -2/7, and the other one's positive 7/2. Perpendicular, okay? Because notice they have opposite signs, and then they're also flipped. Okay, so our answer for this one would be perpendicular. And again, if they're just different, then you just say intersect or neither, okay? So let's try and do, you don't necessarily have to do all of them. So let's do the first four rows here. We already did 2 of them. So row 1, 2, 3, and 4. You can cross out just to save some time. Cross out the bottom 2 rows just to save some time, okay? So again, your goal is that you're trying to find the slope. If it's already in slope-intercept form, just write your slope out. So those top 2 are already in slope-intercept form, so they should be pretty, just write your slope, see if they're parallel, perpendicular slopes, or just intersecting. The other ones, you're going to have to get the y by itself, okay?